problem of the day. Today's problem of the day is an e-maths question, so let's get into it. The expression s cubed plus ps squared plus qx plus k, where p, q and k are constants, has x plus 1 and x minus 2 as factors. If the expression has a remainder of 12 when divided by x minus 2, find the values of p, q and k. So this is a topic under polynomial functions, and this is a problem that you and I are going to solve. So follow along as I'm doing this work, and I wish that you also take your pen and paper and then you solve it yourself, and afterwards you compare your solution to my problem. This is quite a big task, one full question during Wassce time, so please pay much attention as you are solving this problem. Okay, so definitely what we are going to do right now is that we are going to get our expression. In this case, the expression is giving us s cubed plus px squared plus qx plus k, and I'll say let f of x be the expression. Okay, so this time f of x is equal to s cubed plus ps squared plus qx plus k, so that the problem will be very, very simple. So from here it says that x plus 1 and x minus 1 are factors. And then it says if the expression has a remainder of 12 when divided by x minus 2, we are supposed to find these constants. Okay, so I'm going to consider these ones as I break this one down. I'm going to take these ones in here, this and that, which are factors, and then afterwards I'll use that to simplify the problem, and then I'll then move down to this one here that says s minus 2. Let's move on a new sheet so that I can show you something. Let's talk about remainders. When we have something like 10 and we divide it by 2, we believe that we are going to get 5 remainder 0. That means 2 is a factor of 10. What about we having something like 20 divided by, let's say, 5? We are going to get 4 remainder 0. Okay, so these are our remainders. That means when we have 100 divided by, let's say, 10, we're going to get 10 remainder 0. That means 5 is a factor of 20, 2 is a factor of 10, and then 10 is a factor of 100. That means when the number divides another number and it will give you a remainder of 0, that means that number is a factor of that number. Okay, so let me just move to the question here. It says that these are factors of the expression. That means when we divide this expression by these two other expressions, we're going to get 0. So I'm going to take the first one, which is x plus 1. In this case, I want to find the value of x, so that I'll chip in the f of x, and then from there I'll get my answer. So in this case, I'll just do something like x plus 1. I'll equate that to 0, where in this case I'm going to get -1 for the x. So in this case, f of -1 should give me the expression. Wherever I'm going to see x, I'm going to put -1 there. So the first one, which is -1 cubed, from here, which is s cubed plus ps squared plus this, I'm going to put -1 wherever I see x, so plus p, and then -1 square plus q multiplying -1, then plus k. Okay, and then we know that f of 1 is equal to 0 since it's a factor, so I'll just say all of these things, they are equal to 0. Okay, so -1 cube will give you -1, then here would be -1 square will give you +1. That means plus p, and then here -1 times q will give you -q minus q, then plus my k is equal to 0. So from here I can say p minus q plus k, and then I'll bring this here, and then I'm going to get 1. So -1, when crossing the equal sign, it will give me +1. This can be my equation 1. So from there I can also solve for the equation 2. This time I'll use this one, and with this expression, which is x minus 1, I have to equate that to 0 so that I can find x. That means in this case x is equal to 1. So f of 1 should give me 0. That means remainder 0. So from here, wherever I see x, I can put 1 in there, since in this case we had x to be 1. So from here I can say 1 cube plus p, and then here 1 square plus q, and then 1 plus k indeed is equal to 0. So from here I'm going to get 1 plus p plus q plus k to be equal to 0, and then I can say p plus q plus k is equal to -1. In this case, this becomes our equation 2. So with the equation 3 in here, we need to break this down. It says remainder 12 in this case. That means f of this will give us remainder 12. In this case, we have the expression to be x minus 2. We should equate that to 0. So x minus 2 is equal to 0. X is equal to 2. So that means f of 2 should give me 12, since we had a remainder of 12. So from here, wherever I see x, I can put 2 there. So from here, I have 2 cubed plus p, 2 square plus q, and then I'll put 2 here, plus k is equal to 12. So from here, I have 8 plus, this will give me 4, 4p plus 2q plus k should give me 12. So from here, I have 4p plus 2q plus k should give me 12 minus 8. 4p plus 2q plus k should give me, should be 4. This becomes my equation 3. So we have 3 different sets of constants. We have to find 3 different unknowns in these equations. Okay, so first of all, I'm going to take the first equation, but let me arrange them here. So I'll say, with my first equation, we had p minus q plus k is equal to 1, and then that's my equation 1. And then with the second equation, we had p plus q plus k is equal to -1. That's my equation 2. And then with the equation 3, we had 4p plus 2q plus k is equal to 4, equation 3. So these are the 3 equations that we had. So from here, I've seen that k is here, and then k is here. I'm going to consider the first 2 equations, these 2, equation 1 and equation 2. And then I want to eliminate k from these ones, and I believe that will make the work simple. So from here, I'm going to make k the subject in these 2, okay? So with the equation 1, from equation 1, we can say k is equal to 1 plus q minus p. That becomes my equation 4. And then from equation 2, we can also say k is equal to -1 minus q minus k. Minus p. And that will give me equation 5. Okay. So with this, I can equate k is equal to k. That means this is equal to this. So from here, I can say 1 plus q minus p is equal to -1 minus q minus p. Okay, so from here I can group like terms. Okay, so I believe that I'll shift this here, and then I can say q, and then I'll bring this q here plus another q. This p is minus p, this p comes in here to be plus, p is equal to, this is -1, and when this gets in here it will be -1. And then from here I can say 2q, and this will give me 0, is equal to -2. So from here, q is equal to -2 divided by 2. That will give me -1. So we have our q to be equal to -1. We are done with that one. Okay, so from here that I've gotten to realize what q is, I'm going to take equation 4, and then I'll put the q inside it. Okay, so from there I can say k is equal to 1, and then plus -1 minus p. So from here I can say k is equal to, this will give me 0 minus p. Okay, so we can say k is equal to -p. Okay, so this can be my equation 6. All right, so with this one in here, wherever I see k, I can put -p there. So I'm going to take the third equation. So from there I can say 4p plus 2, we believe that q is -1, and then plus k, we believe that k is minus p. All of them gave us 4. So 4p, this will give me -2 minus p is equal to +4. Okay, so in here I will say 4p minus p is equal to 4 plus 2, and this gave me 3p is equal to 6. So p is equal to 6 divided by 3. That gave me 2. So now we have our p. So I can say p is equal to 2. We believe that k is equal to -p. That means k is equal to -2. from this equation, we can say k is equal to negative p. So in here we believe that our q is equal to negative 1, our p is equal to 2, and then our k is equal to negative 2. So this is what we expect you to do with the question given. So we've been able to find our constants. In this case, in here we had p to be 2, q to be negative 1, and then k to be negative 2. Thank you very much for watching this video. I really appreciate your time, and I believe you've been able to get the concept behind questions like this. I actually wish you subscribe to the channel, and you'll see us do more things like this. Until I see you again, stay safe.